This video will use incremental analysis to help us determine how we should allocate a limited resource. And in this problem here, we're going to allocate machine hours that we have available. So the problem I have here says that we have a company that makes steel, and they make three different grades of steel, type 1, 2, and 3. And all of the financial data for each type of steel, 1, 2, and 3, is listed here below, including the revenue, variable costs, and so forth. And so now the problem that this company has is they only have one furnace that melts the steel and makes it into a finished product. And that furnace currently runs 24 hours a day, 7 days a week. So there's absolutely no extra time. They're running at full capacity. So it's considered a bottleneck, and simply meaning that you're limited to the amount of product you can sell because of the time it takes to run it through the furnace. So you can see our problem here. If each type of steel takes this many hours in the furnace, if you add them together, that's 20 hours if you were just to run one of each type. But we have a decision we need to tell our marketing department, okay, if we're going to try to maximize our profit, which type of steel should we focus on selling? So because inevitably we have a problem where we can't get enough steel through the furnace if we focus on selling everything. There's just too much demand. So using incremental analysis, I've set this up this way. We've got the three types of steel or metal that we run, and now I want to figure out my revenue per unit between each of the three types. So how I'm going to figure this out is I'm just going to go and maybe I'll plop something in right here. So I know my total revenues are listed here for each of the three types, but I know this 36,000. If I divide that by the total number of units that are displayed here, which is 5,000, I know each one sells for $7, and I can take that same formula and use it across all three different types of steel. So let me just make sure there's no decimal points hiding here, and there are. So here are my revenues per each of the types of steel. So I'm going to bring those over to here, and I'm going to put them in. Let's just make sure that came across. No, it didn't come across that well. So hold on, let me just find this real quick. Okay, so there are my revenues for each of the three different types, but that's not enough information to tell us, just by looking at this, normal people would say, well, you should run this one because you sell it for more. Well, that's not the case, because we have to figure out because each one takes a different amount of time in the furnace. So the variable cost per unit is what I want to focus on next. So my variable costs are listed right here. Let me just plop in another row here. And I want to get it down to on a per unit basis. So I'm going to take the variable costs in total and divide it by the number of units that are displayed here. And I come up with 5. I'm just going to carry that formula across. And what you'll see here is this is how much it costs in variable cost to run type 1, 2, and 3 in our furnace. So let's copy those over. We'll paste them right here. I got to do this again. Sorry. Okay, so let me get rid of the lines quick. Okay, so now we can now calculate our contribution margin per unit by taking revenue per unit minus variable cost per unit. And so if I do that for all three items, now I get a picture of how much does each product contribute to both fixed costs and profit. And so now, because I only have so many hours available in my furnace, I need to figure out how many hours does it take to melt each type of metal. So it went something like this. It was 5 hours here, 10 hours here, and 5 hours here. Now to get the contribution margin per melt hour, per furnace hour, in other words, I take the total contribution margin for 1 pound or whatever it is of metal, and I divide it by the number of hours it takes on my machine that I've considered a bottleneck. So now what this is my answer right here. This is where incremental analysis is valuable, because what this tells me is that each hour I run that furnace, I'm getting contribution margin of this, or this, depending on which product I run. So given this information, we should tell our marketing department, push this product, do whatever we can to get more orders of type 1 metal, because we make more per hour that it runs in the furnace. Even though type 2 sells for more per pound, this one is the one we should push because we can produce more pounds at almost a rate of 2 to 1. So that is how you use incremental analysis in determining how you allocate a limited resource, and in this case it was a furnace hour, to production.